أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم نبدأ and inshallah we'll start today our video tutorials for physics for MDI. This will be our first tutorial, which will be based on the first worksheet, which is the worksheet number 1 on electrostatics. So let's start. We will start with the first question, and the first question is a little bit somewhat straightforward. So the first question is simply asking you if you have two charges, and he wants you to find the distance between them. So F was defined as Q1 Q2 divided by R12 square, and this is the magnitude. Okay, so if you know the force which is given to you, and you know both charges and K is constant, then you can immediately find the distance between the two charges. Okay, so this is charge number 1, this is charge number 2, and then you just want to find the distance between them if you know the force. So this is given, this is given, this is given, this is given, and the only thing that you don't know is that. It's very straightforward question. I don't want to spend too much time on it because I wanted to spend more time on the other questions, which may be a little bit more challenging. Question number 2. Where's question? Question number 2. I just preset this so that we have the picture in front of us. So what does he want? He wants you to find these two distances. I don't want to read the question because you have it. He wants you to find this distance and this distance, which he called R12, and then R23. So this is 2, 3, and this is 1, 2. And he wants you to find the distance between these two guys when the separation between Q1 and Q3 is 0.2 meter or 20 centimeters, so that the force, the sum of the forces on Q2 is equal to 0. We've done this in class, but we need to sort of quickly do that now. Okay, let me just set it up as usual. Let's just set up the question and then let you finish the rest of the solution. So, okay, so we know that the sum of the forces is equal to 0. That means it's equal to F1 on 3 plus F1 on 2. F1 on 2 plus F3 on 2. So these forces are. Okay. Now, I know that if I take just simply the magnitude, because I know both of them, they are in the same direction. So it's either, well, in this case, they are along the x-axis. So it will be something like this: K, which is the constant, Q1, Q3 divided by R12. I'm going to split the distance. If the total distance between 1 and 3 is 0.2, and Q2 is placed at some, for example, this is x, then this will be 0.2 minus x, or if you want 20 minus x, but make sure this is in centimeter and this is in a meter. Okay, so 1, 3, remember this is 2 and that's 3. Okay, so no, 1, 2. So Q12 divided by x squared plus k, right? Q2, Q3 by 20 minus x all square, and all of this is equal to 0. Okay, so again, as we had before, you see that there are some things that they cancel. For example, Q2 cancels, K cancels, Q2 cancels, K cancels, and then we have Q1 divided by x squared plus Q3 divided by 20 minus x all square is equal to 0. Now the only thing that he told me that Q1 and Q2, they are different. Okay, Q1 and Q2 are different, and of course I want Q1 and Q3. So this is really the Q2 Q2 and the example is really Q3. So what should be given to you, and this is something that please correct because I forgot to correct it in the example. I'm just going to leave this in front of me. In the example, you're given Q1 is equal to 5 times 10 to the power of minus 6 coulombs. Q3, not Q2, that's a typo. Q3 is equal to 3 times 10 to the power of minus 6 coulombs. Okay, so that's the correction there in the exam. In fact, just to make it simple, let's make this 6. Okay, let's make this 6 microcoulombs, and this is 3 microcoulombs. The reason I wanted to do that because I wanted to go back to the equation, and then I have so this will give me that Q1, or I use small letter, Q1 is equal to twice Q3. So when I go back to my equation, Q1, okay, divided by x squared plus 2, Q1 is equal to Q, so this is 2 Q3, and then I have Q3 divided by 20 minus x all square is equal to 0. Now the Q3's will cancel. Now I have a nice equation. The 2 over x square plus 1 over 20 minus x all square is equal to 0. And that I showed you how to solve this in class. Okay, so it's very clear, and I just wanted to check it's very clear. So all I've done, please, you should go back to your to the text or to the worksheet, and these are the givens. So instead of giving you Q1 and Q2, I'm giving you now Q1. I changed it to 6 microcoulombs, and Q3. I just changed this instead of Q2 to Q3, and that's times 10 to the power 6. Please make a note of this. These changes, the numerical changes. And as I said, once you find that, then you go back here. X will be equal to x will be this. This will be your x, okay, and this will be, of course, 20 minus x. So this will be 20 minus x. So R23 will be 20 minus x, and R12 will be simply the value of x after you solve the equation, the quadratic equation, because this is going to be a quadratic equation. Okay, all right. So let's move on. So this is question number 2, which is, as I said, it's a little bit long, but we've done this in class, and this is the idea of zero force that I have mentioned in class. There is a point in space in which you have you can have a zero force even though you have a group of charges. Okay, I'm not going to do question 2 because that's very simple, very straightforward. You have simply you have 2 protons that are separated by some distance, and you want to find the magnitude of the electrostatic force. It's simply you just apply the Coulomb's law. Question 3 is the one that I wanted to do because that's very important, and I'll show you why it's important. Okay, now what is question 4 telling us? Again, I've sort of rewrote or set up this. So he told us that we want the show that the electric force between the electron and a proton in the hydrogen atom is much stronger than the gravitational force between them. So basically he wants you to find, as we see here, he wants you to find the ratio between Fe, the ratio of E to Fg. Okay, now I have an electron and a proton. So Fe, of course I have to calculate first Fe and Fg. Fe simply equal to K, the electron, the charge of the electron, and the charge of the proton, divided by the distance between them square, which we know. Okay, but we may not need to use. Okay, Fg is defined as G divided by the mass of the electron, the mass of the proton, divided by the distance between them square. Okay, that's what the definition is. So if I want to take the ratio between these two forces, so in here I have K E plus divided by, or the charge of the proton square, divided by G M of the proton, the electron, M of the proton, divided by the distance between them squared. So you see this guy will cancel with this guy, and the distance just is cancelled. Okay, and this will be equal to K divided by G multiplied by the charges of the proton and the neutron divided by the masses of the proton and the electron. And then you just have to calculate that. Now I have calculated that in the PowerPoint slides, and you see that when you do that, you see that FE is much bigger than FG, right? And that's why whenever we're let's say considering the forces between the electron and the proton, or the charges in general, the forces between the fundamental charges, oftentimes we ignore the effect of gravity. And this is one reason, because when we compare the magnitudes of the electrostatic charge, the electrostatic force, or the electrostatic force between these two charges, and the gravitation, you see it's very small. The gravitational force is very small in comparison to the electrostatic force. Okay? All right. Let me do one more problem, and then I'll break in terms of just to make sure that the video is short for uploading and for viewing it. So question number 5. Question number 5 is telling me that we have two charges. One of them is plus Q, one of them is minus Q, are located 2 meters apart, and there is a point along the line which is at equidistance from the two charges. He wants you to see or to show which one of these vectors best represent the electric field due to these charges. So remember, in order to calculate the electric field, all I have to do is come in here at the point of interest, which is he wants me to look. This is my point of interest, and I wanted to calculate the electric field here. So what I do, I place a positive test charge, which is small and positive. Okay. Positive so that everybody calculates the same thing, and small so that it does not have any effect on the other, on the force produced by the other charges, or the field effect produced by other charges. Okay, so if this is positive and this is negative, so that means the field due to this charge will be this way. So that's my electric field due to this charge. Let me call it just electric field negative. And since this is positive and this is positive, so the electric field as a vector will be somewhere in this case, and it has the same, by the way, it should have the same magnitude, but I ran out of space. Okay, so anyway, so what does that mean? That means I'm going to have this is going to be resolved into this component, and this is going to be resolved into this component, and these two guys are the same, and one of them is opposite. This is EY, and this is E positive Y. Along the Y direction, these guys will be the same magnitude, so they both will cancel. And then I'm going to have a contribution of this due to that, and another contribution of this. So that means my electric field will be the right direction of the electric field is this guy here, and I just showed that. Okay, so that's question number 5. All right, let me break now, just so that, as I said, the video is short, and then I'm going to come back to question number 6.